Mesomeric effect. This is today's lesson. What is inductive effect? First of all, let's try to recall inductive effect. Suppose this is an organic compound. With this, a group is linked up, which is electron donating group. As it is electron donating group, partially positive charge over this group is created. Similarly, over this adjacent carbon, partially negative charge is created, and this carbon becomes partially negatively charged because this sigma bond is affected by this electron donating group. Similarly, this carbon gets partially negatively charged and this carbon gets partially negatively charged as well. But degree of negative charge decreases gradually, but all the sigma bonds are involved here. Again, suppose this is another compound. Here, this is another group, which is electron donating group. As this is electron donating group, it becomes partially negatively charged. The adjacent carbon becomes partially positively charged. At the same time, these sigma bonds are affected by this electron withdrawing group. And similarly, this carbon becomes partially positively charged. This carbon becomes partially positively charged. Similarly, this carbon becomes partially positively charged. But amount of positive charge decreases gradually. In this case, sigma bonds are involved as well. And this group is called positive inductive effecting group, and this group is referred to as negative inductive effecting group. This total phenomenon is known as inductive effect that involves only sigma bonds. But mesomeric effect involves pi bonds and lone pair of electrons. This is the basic difference between inductive effect and mesomeric effect. Inductive effect involves only sigma bonds, but mesomeric effect involves pi bonds and lone pair of electrons. In this lesson, we are going to learn definition of mesomeric effect, positive mesomeric effect, negative mesomeric effect, and finally examples of positive mesomeric effecting groups and negative mesomeric effecting groups. So let's begin. First point is definition of mesomeric effect. Let's see. For example, a compound nitroethene. This is nitroethene. This bond is coordinate covalent bond. Here nitrogen donated one pair of electrons to oxygen. That is why we can put here positive charge, here negative charge. But this is not essential, so we can delete it. This is nitrogen oxygen double bond. Here driving force is present. Oxygen is a highly electronegative atom. Electronegativity is 3.5, but nitrogen is 3.1. Because of the higher electronegativity of oxygen, pi bonding electrons move towards oxygen completely. As a result, oxygen gets negatively charged, nitrogen gets positively charged. Because of this positive charge, these pi bonded electrons shift to form nitrogen oxygen another pi bond in this way. CH2. Now this double bond becomes single bond. CH, single bond becomes double bond. Here nitrogen, double bond becomes single bond. This is negatively charged. This is coordinate covalent bond. Here this positive charge shifted over this carbon. So because of this nitro group, this molecule gets polarized. Definition of mesomeric effect is polarity in a molecule produced by interaction between pi bonds or interaction between lone pair of electrons and pi bonds is called mesomeric effect. Let's see another example. This is aniline. Amino group contains one pair of electrons. We know these pi bonded electrons move continuously. Because of the continuous movement, phenyl group achieves electron withdrawing nature. Because of this nature, amino group donates its electron pair to form double bond here, and positive charge is created over nitrogen. At the same time, these pi bonding electrons move over this carbon. That is why this carbon becomes negatively charged. Similarly here, it goes to form pi bond. This pi bond turns into lone pair of electrons. Positive charge, here double bond, here negative charge, here double bond. Similarly, this electron pair turns into pi bond, and pi bonding electrons turn into lone pair of electrons. Plus, here double bond, here negative charge. Similarly, it turns into pi bond. This pi bond turns into lone pair again. That is, because of the amino group with phenyl group, amino group donates electron pair to phenyl group. That is why it can be showed in this way. amino group gets partially positively charged, and this position gets partially negatively charged. This position gets partially negatively charged. This position gets partially negatively charged. This position, then this position, and finally this position. These three positions. Actually, this molecule becomes polarized. Positive pole, this moiety is negative pole. Mesomeric effect is defined as polarity produced in a molecule by the movement of pi bonding electrons, or polarity produced by interaction between lone pair and pi bonding electrons, is called mesomeric effect. The basic difference between inductive effect and mesomeric effect is inductive effect involves sigma bonds, mesomeric effect involves pi bonds and lone pair of electrons. Let's move on to the next point. In nitroethene, this is nitro group which acts as electron withdrawing group. In this molecule, this group is mentioned as negative mesomeric effecting group because this group withdraws electron from the molecule and molecule ultimately becomes polar. So in this molecule, nitro group is called negative mesomeric effecting group, and the effect created by this group over the molecule is called negative mesomeric effect. And in aniline, aminobenzene, amino group is donating its electron, lone pair of electrons of nitrogen of amino group. So in aniline, amino group is called positive mesomeric effecting group because it is donating electrons to the molecule, and the effect by this group, amino group over phenyl group, is referred to as positive mesomeric effect. Let's see some more examples of positive and negative mesomeric effecting groups. Positive mesomeric effecting group, the groups that are electron donating groups. We already learned nitro group is electron donating group, alkoxy group is electron donating group, halogens, etc. The groups that are electron donating groups are called positive mesomeric effecting groups, and negative mesomeric effecting groups are electron withdrawing groups, nitro group, aldehyde group, carboxyl group, etc. The groups that are electron withdrawing group are called negative mesomeric effecting groups. This is all about mesomeric effect. No more today. Thank you very much.